Hello, in this lesson we will solve some congruent triangles practice problems. In the first problem, they ask, how do you prove that these triangles are congruent? So we analyze that these two triangles have a common side, 5, a second common side, 4, and a third common side, 6. So these two triangles share the same three sides, 5, 4, and 6. So they will be congruent by side, side, side. In this second problem, they ask, how do you prove that these triangles are congruent? Now, this time I don't see three sides in common, but I see that this side here, AC, is congruent with this side in the other triangle, DF, that this angle 40 is congruent with this 40 degrees on the other triangle. And this side, CB, is congruent with FE. So both triangles share the same side, angle, side. So they will be congruent by side, angle, side. Now here we have a couple of triangles and they want us to prove that they are congruent. The question is what postulate we use, same as the other two problems. This time I see two angles in common, 40 degrees, 60 degrees for this triangle, 40 degrees and 60 degrees for the other triangle. And they also have the same side in between the two angles. So we can prove that these triangles are congruent by angle, side, angle. Very important that you understand that the side has to be in between the two angles for this postulate, angle, side, angle, to be true. Okay, the side is flanked by these two common angles. In this problem, they give us a triangle AED, which is isosceles. And AD is congruent with AE. Okay? So we're going to put tick marks in AD and AE to show that these two sides are congruent to each other. Also, in an isosceles triangle, the opposite angles to the congruent sides are also congruent. So these two angles, which are opposite to the congruent sides, are also congruent. In addition, we know that, or we need to prove that ADC, this triangle here, needs to be congruent to the triangle AEB, by side, angle, side. So that's what we need to figure out here. What information, what missing piece of information is required to prove this congruency by side, angle, side. So to analyze this problem, we're going to split or separate these two triangles. Okay, so again, I'm going to take these triangles and separate them so we can visualize this better. Now, we have the triangle ADC on the right and the triangle AEB on the left. Now, I see that these two triangles have a side in common, an angle in common, and what I need to finalize the side, angle, side is that this other side has to be congruent to each other. And that's the missing piece of information. because the problem is not telling us that BE and CD are congruent. That's the information we need to add to the problem in order to show that these two triangles are congruent by psi angle psi. So the information required to prove this congruency is that these two segments are congruent by basically the BE and CD are congruent. That would be the answer to this problem. If these two segments are congruent, then the two triangles are congruent by psi angle psi. Now, if you don't want to split the triangles to analyze this problem, you can still work with this figure here. So again, you need to analyze first your triangle ADC. That's ADC. And you have to realize that ADC has a side in common to AEB, this red side with a 1 tick mark. Also, AEB has the same side and the same angle, but it's missing the information that tells you that this other side is congruent with this side here. Okay, so again, I repeat, for ADC and AEB to be congruent by psi angle psi, we need information that tells us that this psi is congruent with this psi. That's the missing part. That's the information that we require to be able to prove this congruency. So basically that BE is congruent with CD. Okay? Okay, for this other problem, they give us an isosceles triangle. So we know that, again, once we have an isosceles triangle, the angles opposite to the congruent sides are also congruent, as we saw before. Now, in addition, they tell us that K is the midpoint of the segment MN. So basically, MK and KN are going to be congruent, because if this is the midpoint, it means that this segment is the same, has the same length as this segment. Okay, now that we have established our information on the two triangles, now we can see what we can use to prove this, that these two triangles are congruent. How can we prove them? So I notice that there is a side in common, another side in common, and even a third side in common for both triangles. So both triangles have this 1 tick mark side in common. They have this 2 tick mark side in common. And they have this side that is being shared by both of them, which is the same length for both of them. So these two triangles are going to be congruent by psi, as both of them share the same 3 sides. And when I say share, I mean they have 3 sides that have the same length. So another postulate that we can use to prove congruency between these two triangles would be the psi angle side, because we see both have this side in common, both have an angle in common, and both have this other side in common. So we can prove congruency by psi angle side. Side, angle, side. Side, angle, side. So that would be the answer to this problem. Two postulates can be used to prove congruency between these two triangles. Okay, problem number 6. There are 2 triangular rooms. One triangular room, triangle ABC, has side lengths AB 5 meters, CA 7 meters. Angle B has a measure of 80 degrees. The other triangular room, triangle DEF, is congruent with triangle ABC. What's the measure of DF? We have a lot of words here, but the problem is actually simpler than it looks. Okay? So let's start first with the congruency between the two triangles. We have two triangular rooms. Let's say two triangles. And triangle ABC is congruent with triangle DEF. That's what I say here. The other triangular room DEF is congruent with a triangle ABC, which is the same as saying ABC is congruent with DEF. Now, we know that when these two triangles are congruent, AB is going to be congruent with DE, BC, side BC is going to be congruent with side EF, and the side CA is going to be congruent with the side FD. In the problem, they are asking for the measure of DF, basically this arrow here, right? F to D, which is the same as D to F in length. The lengths are the same. So that's what we're going to focus. FD has the same length as CA. And we already know that CA is 7 meters. If this is 7 meters, then FD is going to be 7 meters, right? And the length of FD is the same length as DF, right? 7 meters. So that would be the answer, right? The measure of DF is 7 meters. Now, problem number 7. Here they give us two triangles again, triangle ABC and triangle DEF, and they say they are congruent. And they want to know what's the measure of X, okay? So we see that the two triangles here, and we want to find X. Basically, we have to work with this angle C. Let's write first the congruency statement. ABC, triangle ABC is congruent with triangle DEF. And again, we want to find out angle C. Right? Angle C will be the same or congruent with angle F, which is 121. So that's all we do, is we establish an equation. 2x minus 1, which is angle C, equals 120. We add 1 on both sides to get rid of that negative 1. We cancel this out. So 2x equals 122, which is 121 plus 1, 122. Now to get rid of that 2, we divide by 2 both sides. So x is going to be 122 divided by 2, which is 61 degrees. This practice problem, they are asking what information is needed to prove that a triangle DAE, right, which would be this triangle here, is congruent with a triangle CBE, which is this triangle here. So we need to see what information, what additional information to what we see here is necessary to prove that these two triangles are congruent. So what I see here is that these two triangles are right triangles. So since they are right triangles, we can use the hypotenuse leg theorem that says that if the hypotenuse is the same, which it is, you see this tick mark here and this tick mark here, thus telling us that the hypotenuse of this right triangle is the same as the hypotenuse of this right triangle. It measures the same. So we just need one leg in common and we prove congruency. So it could be this leg that is congruent with this leg. That will be enough. So if AD is congruent with BC by the hypotenuse leg congruence theorem, then the two triangles will be congruent. The other possibility is that the other leg is congruent to the other leg. So if AE and BE are congruent to each other, then by the same hypotenuse leg congruence theorem, both triangles are congruent. Okay? So basically, every time you see a right triangle and a hypotenuse in common, you should be thinking, if I can show that one more leg is something in common, then the two triangles will be congruent. And that's all for this lesson. Thank you very much for the attention.